supply, which means they have to build power plants big enough to meet everyone's demand.
And as far as the design,
There are two charges.
that's different
fine.
animal, buddy. Life is not fair. As far as the design, when you design something for the light and
Well-
the consumption of a building, you only use 80% of it by
So
code.
the flip side of the story, that's not fair is what you said. The flip side of it is,
So you
if they
use
did,
80, but you get charged 400.
By code, you can't use
the
100%.
flip side of that is, they, when you turn on that switch, they could say, it's not your turn.
I know.
So that's how we get past that argument. Alright, so so what this means in regard to peak load management is I monitor my load, and there's something called real-time pricing.
What is it called?
Real-time pricing. So this value, so this dollars per kilowatt, actually changes throughout the day. Okay? Actually, just about every 15 minutes. Pennies here and there. They sample, the utility rate company samples your meter as a building owner, generally every 5, 15, or 30 minutes. Whatever the largest value they sample in a 1 month period is the rate you get charged at. And there's tiers. So let's say I turn on all my generators at the same time, and they ping me right there.
You're in trouble.
You're going to pay, not only are you going to pay for your demand, right? They know what your building load is, but your charge, your rate will be higher. Well, guess what? That was the only time that you met that, and it was double your average rate. You just got gouged.
Yeah.
And this is
And
random?
this is why we do
Random?
staged chillers, right?
You know,
Random?
No, it's not. It's a set period every couple minutes. There, you cannot.
Oh,
Find
out where is
you can't find out in the middle.
Let me
And
ask
even
you-
if you did, it would they change it sometimes. And you can't
That's
break
not
that
fair.
system.
That's
Let
not
me ask you
No,
this,
that's very fair. And I'll explain why.
So, during our last meeting with IoT, the facilities guys, they said that they want us to look at the off-peak and peak
Mhm.
charges.
That's this.
Yeah.
That's the rate you get charged per
And that's
kilowatt.
something I need to look into, actually. We haven't had the chance to do that. They
What-
don't want us to go with sort of like a one charge.
Yeah. So there's. Let's take that offline.
Okay.
My recommendation to you is when you start looking at utility bills, you get them to bring their key account manager from the utility to the table with you,
Okay.
and let that guy explain how everything works to both of you.
We have, yeah, we have.
We have that. We have the account
we gave us
manager.
some,
Okay. Because he's the guy who holds the keys
have
to how all
common
this
drug.
stuff works.
You know,
We
I
have
told
common
her,
drug.
she-
We have common.
He was going all over the place, and she said, "Oh, by the way, we have to have IIT send me a permission that I talked to you, give
Yep.
me permission." You know, they just try to.
You have the right person.
And
So
she
the amount of
said,
knowledge they have on how the energy market works, which is basically what they do when you're dealing with the energy market, you and I will never get there. They live and breathe it. It's extremely complicated. The math doesn't even make sense all the time. There's charges on your bill that you have to ask what it is.
yeah. So whatever they give us, we're gonna go with it.
Right.
We're not gonna bother.
Now your client asking you to do different rates for different times simply makes your job more difficult. If the key account manager can give you a blended rate
We
that
will
you can
do
just
it.
work with,
Yeah.
the amount of math you can do just goes down.
Yeah.
It makes it easier. Not always possible. I've gotten into that situation
And
before.
for our business case, we have to have that number. We have to have that number.
I have done every kind of energy analysis you can imagine. I no longer do them without blended rates. I only do blended rates. I don't even take into demand charges.
So
It's not
cool.
worth my time.
Okay.
The accuracy changes are so the
Free.
are
Yeah.
so small that it doesn't matter.
Otherwise, you have to run a different, actually.
You have to run different calculation, the
different
spreadsheet gets
analysis,
more complicated, it's not fun. All right, what does all this mean? I monitor my load. When the real-time pricing goes up, I monitor real-time pricing. I intentionally reduce my load to avoid getting pinged for higher usages, for higher consumptions. Run with me? So, example, New York City, energy rate is starts around 19 cents and goes up to about 24 cents per
Wow.
kilowatt hour. Okay, it's 3 times what we are here.
Mm.
I've seen power rates, demand charges over $1.
Yeah.
Who would want to turn down their HVAC at that point?
Nobody.
Okay, yes, right? That's why it's important.
Wow.
Because the reason it's fair is because it's either someone looks at the dollar figure.
Uh-oh.
That's not good. That actually was probably a time clock, not nonsense.
See what happened when you get deep in the
Alright,
lighting?
indeed.
Your
light's gone.
Thank you. So, the reason that's fair is because the alternative to them not raising the rate higher is blackout. There simply won't be enough power for everybody. So because more people are using it, this only happens on hot days, right? HVAC usage.
Yeah.
They start cranking up the rate. And then smart building owners start turning down their HVAC and their lighting and turning on generators. So it basically is a way to, if you don't want to participate, we'll force you into it or you're going to pay for it. It's very popular, or it's going to gain popularity on the coasts. The reason for it gaining popularity in the central of the country is not the same reason, but it will still gain popularity. You think ComEd would rather sell energy to you for 8 cents or to New York for 20 cents? It's a really easy one, right?
No-brainer.
So guess what? If they can get people to start doing their own management, and they start raising this in response to usage, they can force people to not use energy and they can sell it somewhere else. So not the same motivation, right? Slightly different magnitude, but think how much money is on the table for them. So it's not there now. It will be in the future, especially because the discrepancy in energy rates between the coasts and the center of the country is growing wider every year, because 10% of 20 and 10% of 10, right? Very different numbers, very different accelerated growth rates. So that's everything you ever need to know about load shed. Load shedding, peak demand, demand response and peak load management. Smart grid residentially would fit on this chart as well. This is not common. There is a tremendous amount of money on the table with these strategies. Lutron participates in load shed, and we get 10, and we've gotten 5 and 6 figure checks a year for participating in these events. Okay, that's a lot of money, and we're a 215 kilowatt user. We're a quarter meg at our campus. Right. Okay, plug load control. This comes in 2 forms. We have plug load controllers. Zaki, behind you is a coil, what looks like an extension cord. It's probably behind the coffee. Looks like an extension cord. There you go. That is a plug-in receptacle controller. So I plug it into the receptacle. I plug my monitor or my fan or my space heater into it, and it listens to my wireless occupancy sensor. It's a plug-in control, okay, for vampire loads, plug loads. Plug load is the common term. A receptacle control, which is code required now in some places, means I have to control the actual receptacle. I can't have a device that's removable in the mix. Okay?
With the switch.
It just says must be controlled. It doesn't necessarily.
Oh, okay.
It requires an automatic off. An automatic off would be either occupancy sensor or time clock switch. Okay. That's the only difference. One's removable, one's not. To meet code, it has to be a permanent installation. It must control the receptacle itself. It's always an on-off circuit, and the control mechanism is the only requirement they tell you is it's an automatic off feature, which means it has to be occupancy off, not the on event, just it has to be a vacancy event, and it also must or it can be time clock off. Okay, the on event they don't dictate. There's debate going on whether manual on or automatic on is the right approach. It depends what you're plugging into the outlet. If you're plugging into a machinery, auto on is probably not the right solution, right? If you're plugging in your computer monitor, auto on is probably right. Okay? So again, you evaluate it space by space, need by need. Again, it is a new code requirement for the new ASHRAE codes, and it does come from California. Really, this savings, as an engineer and as a retrofit company, you'd have to, if you really wanted to dive into the value there, you'd have to evaluate what they're going to plug in, and the client's going to have to basically, sign the dotted line saying we're going to plug what we told you we're going to plug it into it. Right? Typical uses are printers, computer monitors. Don't think of your one computer monitor, but think of a financial trader with 6 monitors. Now you're talking about a lot of power, but guess what? Even in sleep mode is consuming a watt or 2, right, an hour, over 6,000 unused hours a year. It's a lot of energy you're leaving on the table per person. These are very easy ways to get extra savings out of that building. Computer towers, you don't turn off because they have a boot cycle. If everyone's operating system started up in 10 seconds, we would put everything on this. But because some things take time to warm up, like your big copiers, you probably don't want to cycle that off every time someone leaves the room. This is a brand new market. This is being product-wise as well as sequence of operation-wise. This is an open negotiation. This is still being defined today. We are participating in that, trying to lead the industry what they should do. And I guarantee you, I have more understanding of the sequence of operation of that than most specifiers. My job is to think like that. And then the last thing I have here is integration. Why put in 3 systems with 3 different aux sensors when I can put in one aux sensor and share that information between systems is one example. Right? It's the open access of information. If we're going to build a building, it probably would be a good idea if the HVAC guy, the building control guy, the security guy, the lighting guy, and everybody else actually spoke to each other and designed the building intelligently instead of having 3 occupancy sensors on the ceiling, or instead of putting 6 different time clocks in the building. So the 3 ways that Lutron can achieve this is via contact closure, really easy, really simple, lots of wiring. Right? A simple example of that is a occupancy sensor that has 2 outputs. One that goes to a lighting relay locally, and one that has a secondary relay that goes to a VAV box, variable air volume controller in the room. When I leave the room, the lights go out, and I don't close the damper, but I close it more. You can't close the damper because there's ventilation requirements even in unoccupied space, but you can reduce them.
Dim it.
Dim them, exactly. I don't know a good word for it.
Stepping.
Right. Now that's a hard construct. Once I install that, that's the way it works. Right? It's point to point, open, close, kind of. That's it. There's very little flexibility there. Ethernet and RS-232 is generally used for AV integration. So if I wanted to have a touch screen and I wanted to be able to control my audio-visual controls, choose my input, my video input, choose my audio input, I want to be able to change my lighting level and move my shades, that typically requires 2 companies to talk, like a Crestron or an AMS or a Control 4 has to talk to other manufacturers. The communication language is Ethernet or RS-232, which is basically serial commands. Our serial command set is published. Anyone can go download and write drivers for it. And the last version that we use is called BACnet. It's a building communication language. Other examples of it are Modbus, Lawnworks, BACnet over Ethernet, and BACnet MSTP. We hang our hat on BACnet IP. That IP, that second part of BACnet, is very critical. A system that speaks BACnet IP and a BACnet Ethernet system are not compatible. Okay? We are the only lighting control manufacturer that has a system certification for BACnet. You can go to the BACnet testing laboratory website, and Lutron will appear as having a system compatible that meets their standards. There are other manufacturers have components that meet the standard, like a relay cabinet, but not a whole system. And we can talk about the distinction some other time. It's a very, very large distinction.
So the reason is the Ethernet and BACnet are not better because of the different protocols?
Ethernet and IP have different protocols. Okay? It's still BACnet, right? The same body governs it, but the packaging of the messages are different, and they're not compatible. And IP, to my knowledge, and knowledge of everyone I've ever spoken to, BACnet IP is the most widely spoken language, building language, and more people are going towards it. Most of the BMS manufacturers have multiple language availabilities. Most of the opposing third-party control systems like lighting hang their hat on 1 or 2 of them, and each of them have a different. So all the BACnets are very similar. BACnet IP BACnet is standard. It's very, very common, and BACnet IP is the most common of all the BACnet languages.
Even in Europe?
In the States, I'd have.
Because in Europe we have something.
I think KNX is popular, and I know Lawnworks is popular.
What do they use in Europe, sir?
I don't recall because when we designed, we used Lutron for the project in Qatar. We had some issues.
It would have been BACnet. It might have been a different protocol.
Okay.
So I'm not going to get into it. These are things that you will run into if you're looking at building management systems or energy management systems or building automation systems. They're all the same entity. Lutron speaks BACnet IP. Okay? These other ones are physically different architectures. If you were to learn about these things, where the intelligence is changes in these different platforms.